So here we are, just gone from the MF radar transmitter hut, the Erebus Hatherton Lab, where the data ends up going to, and then onto the real world. Hillary's hut, the old TAE hut. That's the Ionosonde mast. Right beside the Ionosonde mast is the Geomag variometer hut, and over there is the Absolutes hut for the Geomag, with Discovery in the background. So we'll go inside the variometer hut and have a look around. It's normally not allowed any metal in here. We have to log the time that we go in and out so that we don't contaminate the record. There's a little cold porch here. That's where they used to have the old system set up. Inside here, not touching anything. Here we have the old DSIR designed 3-component system, so you can see flux gate, tubes, east-west, north-south and vertical component. That's the 3-component system, the old one, which is just left here for historical purposes, but could be reconnected. This here is the equivalent modern day instrumentation. So it's a 3-component system. We have loggers down there in the Pelican case. This here is a proton magnetometer with GPS. So it gets timestamps. That gives you the total field, and its sensor is up there on the wall. So with the 3-component system, you get the 3 angles, the 3 components of the field, and that bottle up there and that instrumentation package down there give you the magnitude. So with the magnitude and directions, you have the whole field established. So just been inside to look at the variometer hut, and we head towards the Absolutes hut. So the variometer record goes every second. It takes a measurement, but the instrument could drift over time. Could be a shake on the building which could move the sensor. So every week we do an absolute measurement to ground truth the variometer record. Just notice on the back of the building there's a little white cross with triangles on it. That's a site marker. So we use that, and it's a little light above it for in winter so you can see it. So that site marker is used to go through a tiny little porthole in that door that Wills is just opening. And that porthole is used to site that site marker for the theodolite that's in there with a magnetic sensor on its head. So we can measure a reference marker and magnetic east-west, and then that gives you the declination, and then we flip the telescope over to get the inclination. So we can get the 3 components, and we have a magnetometer in here for total field as well. So we get the 3 components and the total field to give you the magnitude to give you the total field absolute. So that we bottle there is the sensor for the rather old now proton magnetometer that was designed by DSIR in the 80s. There's its readout over there. This is a null meter, so that is used, and it goes across to the magnetic sensor here on this telescope. So the telescope can move up and down and left to right, and we can use the readings from that. When we get a null, the null means that the field lines are going through the solenoid, across the solenoid, rather than through it. When you go through, you get a maximum. Across it, you get a null. And when we know that, we have the sensor completely horizontal, and we get a null, we know that the field is maximum in this direction and minimum in that direction.